Hey everyone, get ready for a deep dive. It's going to be electrifying. We're diving into the world of data
The
centers.
powerhouses behind the digital world.
Right, they're everywhere, but we don't really think about them.
Yeah.
All those servers storing our data.
And running those apps that we're all, like, glued to these days.
Exactly. And today we're talking about the hyperscale ones.
These facilities are using as much power as small cities.
It's incredible.
It is pretty amazing.
So to help us break it all down, we're looking at a report called Data Center Anatomy Part 1, Electrical Systems.
From semi-analysis, it's a good one.
Yeah, and we're going to go all the way from the power grid to the chips themselves.
It's going to be a wild ride. But with AI using more and more juice, we've got to understand this stuff.
This is the infrastructure of the future.
Okay, so we're talking about some seriously big facilities here.
Oh yeah, imagine a single data center powering like 200,000 homes. What? That's insane. But let's back up for a sec. Before we get too deep into hyperscale, can we clarify some terms? We've got colocation, we've got self-build. What are those again?
So colocation is basically renting space in a shared data center.
Okay, so you're sharing resources with other companies.
Exactly. Kind of like renting an apartment in a big building. Self-build is more like, well, building your own house.
You've got complete control.
Yeah, you design it, you build it, it's all you.
And much more expensive, I imagine.
You better believe it. And then there's critical IT power. It's a mouthful, but it's important.
Right, because it refers to how much power your equipment actually needs to run.
Exactly, like at its peak performance. Can't forget that.
Absolutely. And then you've got the different levels of data centers. Retail, wholesale, hyperscale. It's like a whole ecosystem.
It's all about scale, really. Retail data centers, they're like the corner shops of the data world, serving smaller businesses. You get your wholesale data centers, a bit bigger, serving larger clients, and then
Yeah.
hyperscale.
The big leagues.
Yeah, those are the massive facilities we're talking about today.
Okay, so let's picture it. We're a jolt of electricity, fresh off the grid, heading into a hyperscale data center. What's the first stop on our journey?
First stop, the substation. And for these mega facilities, it's often on-site.
That makes sense given the amount of power they need.
Right. But here's the thing. You can't just pump all that high voltage straight into the servers.
That'd be like plugging your phone charger directly into a power line.
Pretty much. High voltage is great for traveling long distances, but inside a building, it's way too dangerous.
So I need to step down the voltage, right?
Exactly. That's where the MV switchgear comes in, like a pressure regulator, making sure the electricity is at a safe level.
Okay, so we've been regulated. What's next?
Next, we hit those crucial transformers.
The report has a cool diagram showing this whole power path. It's like a roadmap for electricity.
The transformers are like the bouncers of the data center, making sure the electricity is right for all the sensitive equipment inside.
It's incredible how much thought goes into protecting those servers.
Oh yeah, downtime is a data center's worst nightmare.
Can you imagine like a website crashing because of a power blip?
Chaos. So they have backup systems like generators.
Like a giant backup generator for your house.
Exactly, but on a much larger scale. They have automatic transfer switches too, ATS for short.
To kick in if the main power goes down.
You got it. And don't forget the UPS, the uninterruptible power supply. Basically a giant battery backup, making sure everything keeps running smoothly.
So even if the generators take a minute to spin up, the UPS has got our back.
Exactly. No interruptions allowed.
Okay, so we've navigated the substation, the switchgear, the transformers, the generators, and the UPS.
That's a lot of power protection.
It is. Where does the electricity go from there?
Well, next up is distribution within the data center itself.
So how does it get from the power source to all those individual servers?
Think of it like the roads and highways inside a city. The electricity travels through busways or PDUs, power distribution units.
So the busways and PDUs are like those local streets delivering power to all the different buildings.
Exactly. And finally, we've gone from the power grid all the way down to those servers powering everything.
It's like a journey.
It really is. But it's about to get even more interesting because AI is changing everything.
And that's where that story about Meta's demolished data center comes in, right?
Oh, yeah. That's a perfect example of what happens when you underestimate AI's need for power.
They literally tore down a half-finished data center. Just like that.
Yep. Meta, Facebook's parent company, they designed this facility with energy efficiency in mind, which, was a big deal at the time.
So what happened? They were too efficient.
In a way, yeah. They didn't fully account for how power-hungry AI workloads would become, especially things like large language models.
So their energy-efficient design couldn't handle the heat from all those AI tasks.
Yeah, basically. They needed more power density than they'd planned for. AI training requires a totally different approach.
It's crazy how fast things change. What seemed cutting edge a few years ago is already obsolete.
That's the AI game for you. Always moving, always pushing the limits.
And pushing the limits of those data centers, too. So how do companies keep up? Are we talking about like a total redesign?
Pretty much. One of the biggest challenges is density, trying to cram more and more processing power into a smaller space.
Because the more AI we use, the more power we need, and the more space those servers take up.
Exactly. And those GPU clusters we talked about, they're power-hungry beasts.
Right, and the report mentioned NVIDIA's GB200, something like 130 kilowatts in a single rack. That's more than my house uses in a month.
That's the future right there. 130 kilowatts all packed into one rack. It's mind-blowing the amount of power these things need.
Okay, but hold on. All that power in one place, won't it just overheat, like melt down?
That's the million-dollar question, isn't it? And that's where cooling comes in.
So those giant fans we always see in data center photos, those aren't enough anymore.
Not even close. We're talking about a whole new level of heat. Air cooling just can't keep up.
Okay, so what's the solution? How do you keep these things cool?
Liquid cooling. It's the only way. Remember that winners and losers part of the report?
Yeah, you said it's behind a paywall, though.
It is, but they hinted some interesting stuff. Liquid cooling is going to be a major factor.
So are we dunking these servers in giant water tanks now?
Not quite, though some companies are trying that, believe it or not. It's called immersion cooling. But the more common way is circulating liquid directly over the hottest parts, like the CPUs and GPUs.
So giving each server its own little radiator.
Basically, it's way more efficient than air cooling. You can pack more power into a smaller space, and that means more computing power per square foot.
Which is what it's all about, right? More power, more density.
Exactly. And remember that prediction we talked about earlier? The 14.8 kilowatts per rack by 2030.
Seems a little outdated now, doesn't it?
Totally. AI is moving so fast, we need to be thinking bigger, bolder. It's not just about keeping up, it's about staying ahead.
And that means rethinking everything. Power, cooling, even the design of the data centers themselves.
It's a whole new world of engineering. And the companies that figure it out first, they're going to have a serious edge.
So we've got these super powerful systems, liquid cooling to keep them from melting. What else? What does this mean for the future of data centers? Are they just going to get bigger and bigger?
That's the big question, isn't it? Bigger isn't always better, though. The report, even though that section is paywalled, hints at some other trends, too. Companies that really understand power management, thermal dynamics, they're the ones to watch.
So it's not just about plugging things in anymore.
No way. It's about being smart, optimizing every watt of power, every degree of heat.
It's not like just throwing more computing power at the problem is going to solve everything, is it?
No, not at all. It takes a lot of brain power to manage all that power.
Yeah.
You need people who really get power management, thermal dynamics.
It's a whole different ballgame, isn't it?
Totally. It's not your dad's data center anymore. We're talking serious science here.
Data scientists working alongside thermal engineers. Who would have thought?
Right. It takes a village to train a large language model.
That's a good one. It really highlights how interconnected everything is, doesn't it? The AI needs more power, so you need denser computing, but then you get more heat.
It's a constant balancing act, for sure.
You need these new cooling solutions. It's like every innovation leads to a new challenge.
And that's what makes it so exciting. It's a never-ending puzzle.
So we've talked about liquid cooling. What else is out there? What's next for data centers?
But one thing that's really interesting is renewable energy.
Oh, yeah, that makes sense. Data centers use so much power.
Exactly. As we move towards a more sustainable future, we've got to think about where all that energy is coming from.
So instead of just relying on the grid, we could see data centers powered by, like, solar farms or wind turbines.
Exactly. Imagine a data center right next to a hydroelectric dam. Constant, sustainable energy. Or picture this. You've got your massive data center, and the whole roof is covered in solar panels.
Generating their own power? That's amazing.
It makes a lot of sense, right? And it could even change where they build these things.
Because now it's not just about finding cheap land and cool climates.
Right, you want to be close to those renewable energy sources too.
So instead of those massive server farms in the middle of nowhere, we might start seeing them popping up near wind farms or in sunny deserts, right?
It's definitely possible.
It's like something out of a science fiction novel.
I know, right? The future of data centers isn't just about bigger and better tech. It's about being smart, being sustainable.
Absolutely. Finding ways to support this incredible digital world without, overloading the planet.
Exactly. It's about finding that balance.
That's a great note to end on. We've gone from the nitty-gritty of power grids and transformers
Yeah,
to imagining a future where data centers are powered by the sun and the wind.
it's been quite a journey.
It really has. Well, that brings us to the end of our deep dive into the world of data centers. We've explored the technology, the challenges, and even caught a glimpse of a more sustainable future.
All powered by AI, of course.
Of course. As always, thank you so much for joining us. It's been a pleasure picking your brain.
The pleasure was all mine. Always happy to talk about the future of tech.
And to our listeners, thank you for tuning in. We'll be back soon with another deep dive into the fascinating world of technology. Until then, keep those curiosity circuits firing.